like a lot of kids, I played with a lot of blocks and Legos, and it just sort of took off from there. It became, well, I guess, a bit of an obsession. That's pretty much the only toy I played with as a kid. It was all about building things for me. That's just sort of how my mind worked, all the spatial orientation stuff, and just sort of all was something I was fascinated with, how things come together. In grade school, it's just about paying attention to math and sciences, and in high school, taking a lot of the STEM classes, the math, sciences, and even some of the sort of pre-engineering classes. But it was also about the English, and the philosophy. All that stuff helps you relate better to a lot of people, and you need that to succeed in engineering, believe it or not. The college degree is necessary. I have a Bachelor's of Science in Engineering and also a Master's of Science. In structural engineering, it seems to be going towards getting your Master's is fairly important, because you just can't learn enough as a bachelor with a bachelor's degree. And in college, again, I took a lot of classes that were obviously not just the engineering and the sciences, but again, the Englishes, and a well-rounded education is really important. I think employers are looking for that, and it's certainly something that's needed to succeed. Well, a lot of people think that engineers just go to their desk and put their head down and do a bunch of calculations and drop a bunch of stuff, but it's a lot more than that. I spend a good half of the day away from my desk. It's a lot of team environment stuff, working with people, working with lots of different kinds of people, but using other skill sets besides just your engineering skill sets. A lot of communication, a lot of team building. I spend a lot of time writing proposals to win new work, to help win new work. I spend a lot of time on presentations to clients. Again, it's a lot more than just sitting down and cranking through numbers. It's about making sure something stands up that's designed. That could be something that's fairly fantastical, that an architect could put together, and a structural engineer puts the bones underneath it to make sure that it stands up and it is a safe environment for people to be in. Everything's connected inside of a building. You change something here, it changes something someplace else. And so we do a lot of analyses that, again, make sure that the building is strong enough, or the structure is strong enough, but also we want to make sure that things like it doesn't vibrate too much where it's uncomfortable for people. In certain areas, we make sure it's safe during earthquakes. There's a whole lot more that goes into it than just building something that will stand up by itself. That's pretty easy. It's just that you get to see what you've done. You can walk around a city, you can walk around places and point to say, hey, I did that. It's a real tangible experience doing this stuff. And it's big. A lot of it can be really big, and I think that's pretty neat. There's other types of engineering, a lot of other types where you just don't really get to see your contribution to society, but here you do. I work with all sorts of people, architects, but also things you wouldn't necessarily think about, environmental scientists. We might be putting something in a environmentally sensitive place. We have to deal with hydrology and hydraulics on projects. We have to deal with just plain old civil engineering, the roadways and traffic signals that lead up to projects. A total project isn't just about the structure. It's about a lot of things that have to come together. On a day-to-day basis, I also work with proposal writers, with accountants, with legal folks. It's all necessary in our business.